All right, so we are going to actually go over this little notebook. So, and we're going to kind of go through a little bit. So if you've already gone through topic one, you would actually know pretty much everything I'm saying. But we're going to kind of go through this together just to introduce to you a few things. So first of all, we say, what is data science? So before we kind of really go through like at least my version of what data science is, does anyone want to kind of chime in and say, how would they describe data science? Like, I'm sure you have partners, family, and friends who you've said like, hey, I'm doing this data science boot camp. And they go, what the heck is data science? So does anyone want to take a stab at it of what they would call it or how would they explain data science? No volunteers? Got a quiet bunch. All right, that's okay. Next one's going to be awarded 150 brownie points, which are not redeemable for anything. All right, so the way I would describe data science is really just taking data and trying to find meaning out of this information. And so I like to say is that there's a difference between data and information. Data are just points of representing real world um, real world attributes. So like you can think of like, everyone's age here or everyone's, location. That would be data, right? But that information in a lot of ways, it's like you need to actually look at that and say, well, what does that mean then? Like, what do we, when we look at the ages, let's say, for example, age is a really easy one to think about. Is like, if we look at everyone's ages, we can have a list of everyone's ages, but then does that mean something to us? And is that something that we need to actually, like, is there something we can do with that information? So with a business, and usually we talk about like, you'll hear me say business problem, business understanding. Note that data science is not limited to just like a business. It could also be like, you can be like nonprofit or other organizations and stuff like this. But you'll hear me say business a lot, is that you can say, okay, like if we understand what our customers look like, like what are the things that they care for? What are the things, relationships, that they have with products or other, other members or whatever, is that you can grab insightful meaning from that data. And that's really what data science is about. It's basically saying, hey, can we collect this information, this data, and actually give meaning to it and bring actionable meaning, which is like summed up pretty quickly, but that's a lot to ask for, right? Like if you think about it, like how do I get all this information? How do I get all this data? And then after I get all this data, how do I sift through it to actually like find anything meaningful? Like imagine having like hundreds, thousands, if not millions of rows of information and saying, what can I find from here? Basically, what kind of patterns can I find? And then saying, after you find those patterns, say, okay, but how is this useful for us? Like, what can we do with this as our organization? And that's really what data science kind of, I would say sums down to. Now, I will say is that you'll hear me use the word data scientist. And I am someone who thinks that data scientist, the way, however you think, whatever your picture of a data scientist is right now, is probably not going to be the same consistency in like 5-10 years. I think I personally think that data scientist role name will kind of change and morph it because it already has so much. And it just depends on what area of the data science, what we call the data science life cycle that you're at. And you'll see this is like, sometimes like a very nice, like, straight line or, a circle like this one. And it makes it look very nice and neat. It's not as clear cut in the real world. But it kind of helps us organize our thoughts and things. So the first part of like the data science lifecycle is basically saying the business understanding of saying, what kind of questions can we ask and how can they actually like help us define an objective so we can actually attack a problem. So that's kind of like the very first step before anything else, before you touch data, before you do anything technical, is really understanding what is the problem I'm trying to solve and what would it take for us to solve this problem, and like what is the benefit. So you can think about a whole bunch of different problems in there. Like you say, oh, we need to, increase our membership. We need to increase, like look at our churn rate, make sure like we're keeping customers. We can say like, hey, we want to build a self-driving car, like all these things are problems. Say, what are the things that we need to start off? Like, what is the problem we're trying to solve? And then from there, we can just find what data we gather and how we're going to use that data. Okay, so that's really like the step one. All right, I think I heard someone unmute. Feel free if you have a question, like unmute and interrupt me. Okay, So the next step is really data mining, and this people are going to call these different steps different things. Some people are going to combine these steps together. But data mining or data collection, that's I usually think of it like more like data aggregation, is basically saying like, where do you get this data from? And that's a whole different step. You can scrape the web. You can go to another website and actually look at what's on that website already and pull that information down. Data mining can also be literally like having some other device that's in the physical world that is recording information. So think of things like if you're talking about agriculture and irrigation, maybe there's sensors for your irrigation system that can give you information to help you better apply resources or identify when, for example, let's say like, irrigation like spout or something like that, it's not functioning properly. Like that can be getting information. This can come in a whole bunch of different forms. And this is usually after you find out what problem you want, you figure out, well, what kind of data can I grab and what can I actually do with this? So it's kind of like that initial step. Then we have data cleaning or data munging, all that stuff. Basically, the idea is that you have this raw data, we kind of call it, and we kind of like cook this data so it's in a nice process form that we can actually do something interesting with it. On the extreme end, you can think of things like binary digits, right? Like binary ones and zeros doesn't really help you much by itself. But if we understand, like, okay, like, well, this string of zeros and ones means the number 5, that's actually information. That's actually like a really low level, you're usually not doing it at that level. But data cleaning can be like, hey, like we are getting a bunch of huge negative values for the battery percentage of this device. And you're like, what the heck? Like negative, like doesn't make any sense. And maybe there's some issue with either the sensor, maybe it's an interpretation of how things are. A typical thing, kind of spoiler, is if you look at ages and people can submit their ages in like data sets, you'll see huge spikes on very specific ages. And it's not because there's suddenly a huge number of 100-year-olds, people. It's because people don't want to share their age and they've just put 100 years old. So you can kind of see like, well, okay, we don't want to actually trust that data, even though that raw data does exist. And someone said, I am 100 years old. It's unlikely that all these people are also 100 years old. And that's part of data cleaning too, understanding your data and saying, hey, how can we actually bring out meaning from this? Okay. Does that make sense to people? Yeah. All right. I like using the thumbs up, thumbs down, sideways if you're feeling good. All right. I wish I could see more people at once. I think it's not mostly thumbs up. All right. So next step really is like data exploration. And this is when it's like, okay, we kind of clean this data. This is kind of a back and forth a lot of times. The data exploration basically trying to figure and understand, okay, now we kind of got our data into a form that we can actually look at. Okay, what can we observe from it? What kind of patterns can we kind of check out? And this is where for data exploration, you might be doing some visualization. You might be doing statistical analysis, some hypothesis testing. This is the idea of like trying to explore and understand the context of your data itself. Okay. And then we get into feature engineering, which is going to be associated with predictive modeling. Feature engineering basically is saying, hey, we have all this information, but not all this information is relevant to the problem that we actually want to address. So what information do we need to keep? What information do we need to modify? What information, maybe we need more information that we don't have. We have to go back to data mining. That's what this feature engineering part is. And with this feature engineering, usually that leads into predictive modeling. I personally don't like a lot of times when the data lifecycle talks about like predictive modeling as if like that's the next step, because that's not always true in a lot of data science positions. But I think it's a good like kind of like focus is that now we say, hey, we have this information. How can we predict? How can we think of like what the data will look like in the future? Like as we get new information, like what would that look like? So for example, if you looked at like new customers coming on board and you're like, hey, a lot of these new customers really like these items, then future new customers, like maybe those future new customers will also like these items too. That's the idea of predictive modeling, basically using the data you have already to get an idea of what future data will look like. Okay, and this is where machine learning, all that good stuff comes from. And this life cycle diagram, it has data visualization afterwards. I like to say more like presentation of information. So this can be to another data science team. Maybe this could be internal to your team. Maybe this is just in a sense of you to kind of like collect everything together into a report so that you and other people can understand it. This can also be presentations to what we call like non-technical stakeholders. Your stakeholder, basically the people who care about the thing that you're talking about, and non-technical meaning that they might not be data science, they might have data science, literacy. They might not know what data science is, but the stuff you're going to talk about are probably really relevant to them. And that's where you actually talk about doing explanatory visualizations and showing what is important about the data that you've already pulled together. Okay, cool. And then of course, with that, you might go into a new problem. Say, hey, well, okay, that does fix this problem, but now it actually shows a new thing that we can look into. And you can imagine this whole thing going over again. Okay, sound very good. Any questions on that? And that might have sounded kind of almost a little too smooth. It definitely is not. Like, it definitely is a lot of back and forth between different sections and stuff. So just know that that does exist. Okay. All right. So now that we talked about data science, like, all right, cool. Like, what do we do? So there's some tools. So one of the tools which you should set up in topic 1 is your Conda environment or Anaconda environment. So kind of quick thumbs up, and I'm gonna actually have you keep your hands up if you are, you just, who has set up their Conda environment that is described in topic 1? Just give me a thumbs up if you have, thumbs down if you haven't. Okay, I just want to get a feel. So keep it up or down. Cool, cool. All right. All right, I think I see from the people who have their screens on, I think I mostly see like actually mostly thumbs down, which is okay. That means you're gonna have to set up. So we'll actually make sure to spend some office time to do that. Make sure you follow topic 1, especially if you have a Mac and Windows. Does anyone have something that's not a Mac or a Windows PC? You can speak up if you're not shy. Cool. All right, so we're all Windows and Mac then. That makes my life easier. I once had someone try to do a Chromebook, and I'm like, ooh, like Chromebook, I've been down that route. That's not an easy one to deal with. And they ended up saying, yes, you're absolutely right. So good. So make sure you set this up. But Anaconda, you can imagine it as being, it's actually a huge suite of information, and it's a very popular one. Pip is also a similar kind of thing. It's actually built within Python, but Anaconda basically allows us to, it manages packages and manages other code that other people have written called libraries or packages, and that we can reuse ourselves. So some very, like, ones you're going to hear over and over throughout this course is like scikit-learn, sometimes abbreviated sklearn. We'll see things like, if you talk about deep learning, is TensorFlow. Pandas is a Python data science tool that's really great for organizing information and plotting things out. Matplotlib, you'll see all these packages. And what's nice is that, well, I should say what's not nice is that they can have different versions, and these different versions can really be a big issue. And so sometimes there's incompatibility because you have different libraries, different packages, basically different code that other people have written that are not necessarily compatible together. And so making sure you have the right packages when you share this code for other data scientists, or even yourself when you look at it later on, like maybe like, let's say you write this like a year ago, and then someone says, hey, remember that project you did a year ago? Let's check that out again. And you've already upgraded to the newest version, your code might not work. So Conda basically creates something called a virtual environment, which basically is kind of like, you can kind of think of it like a mini computer within your computer of like things that are installed in a certain way. And that way you can make sure everything works properly. It's basically as expected and stuff like that. So that's where Conda is really useful. And that's where we do Conda. And we'll kind of walk that through maybe during office hours to make sure everyone's all set up. Real quick, I did want to mention is that if you go through the installation, make sure, let's hear, installing on a Mac. No, okay, I'm not going to go through this right now. But I did have once someone install on Anaconda on Python 2. Do not do that. Make sure you're on Python 3, preferably the newest version, which I think is 3.8, which is available. They didn't tell me they had Python 2, and they knew it for like a month, and that was a whole bunch of fun issues. So that's why I'm going to make sure that I'll make sure we're up to speed too, and we'll do that during office hours and throughout this week. Okay, that's step 1. Okay. The other tool is Jupyter Notebook, which is actually what I'm using right now. Jupyter Notebook is not the only tool to use for data science. It's based off of something called IPython notebooks, which used to be a command line terminal. Jupyter Notebooks is pretty mature. You'll see a lot of tools that are like, for example, we'll talk about this in the future, but like Kaggle and Colab, which basically is like a split from Jupyter Notebook. So it's very similar. It's a very common thing. It's not perfect, I will tell you, is that there are definitely some voices out there that say Jupyter Notebooks could be better, or are doing something that they shouldn't be. But we'll talk about those nuances, but this is actually what we'll mostly do work with and everything. So again, it's a really great tool. It's a little confusing because there's two different things. There is Jupyter Notebook, which is the actual program. And then there's notebooks, which are the actual like instance of file. And so you actually see here, oh, my Zoom thing was getting in the way. You can see his .ipnb extension right here. That is a specific file name saying .ipython notebook. And that's actually what Jupyter Notebooks can open up and actually edit. And that's actually what you're seeing right here. In fact, if I look at this URL, no, this is a URL, but this is actually on my own computer. We can talk more about that in the future. But you can see here, that's the actual name of the file right here, and that you can interact with. Okay, cool. So this is actually going to be installed with Conda. I think if you install Conda the way the curriculum shows you, you should get Jupyter Notebook also installed. And of course, if you have issues, we can talk about that, right? And make sure we get things fixed. Later on, we'll talk, I might show you guys some extensions once you kind of get the feel for Jupyter Notebook. For example, like this little code folding thing right here, or these little cell foldings, is not built into Jupyter Notebook by itself, but there are extensions you can add to kind of add extra functionality to this. So this is actually something that's really useful. And you can see here Conda being like Anaconda, right? So you can see how this can be installed here. While I'm still talking about Jupyter Notebook, we'll see more about this when we talk about our actual Python stuff. These individual, you can see like this blue highlighted and this other blue highlighted, these are called cells. And so each little cell can be written in. And in fact, if you look at this right here, it looks like an image. I actually have some little bit of code right here that actually says where that image comes from. So we'll talk a little bit about like what that looks like too. But basically what's really nice about notebooks is that you can comprise all of your code and what I say, like your like kind of like extra notes that are not code all within one file, which can be really convenient, especially when you want to show things to another data scientist or even someone who's not a data scientist. It can be useful for making reports and making something that's a little more interactive and a little easy for them to go through versus like saying, oh, here's this file code and run this in the terminal, which can be kind of intimidating for some people, or, you know, can be a little more difficult to navigate if you're not used to that. So Jupyter Notebook's a really useful tool. Okay. Cool. All right, I realize it's got about like 20 minutes for the hour, so we'll probably go a little bit longer. That's okay. First day, so that means we get lots to talk about. All right, Git and GitHub. So who's heard of GitHub? Thumbs up if you had. All right, I see some. Okay, I think most people have heard of it then. All right, cool. So Git and GitHub are almost like synonymous. Like we talk about them almost all this like at the same time. Git is actually the tool that we use for something called version control. And GitHub is actually a private company. It's actually owned by Microsoft that uses the Git versioning tool. And you can actually share your code through communities and stuff like that. In fact, that's why I mentioned like clicking that little button, it opens GitHub. That's what this is talking about. This little comic, if you guys haven't heard of xkcd.com, this is pretty, like they pretty much have every relevant like data science like and programming joke, like it's always you're gonna see a lot of these kind of comics from me. But this is kind of a summary of this. Like Git is this really amazing tool that everybody loves, you know, says, oh, it's so great to do this. And then and it's, but how does it work? It's like, I don't know how it works, but I just do these certain commands and it works. And so you'll hear a lot of that. I've known people who've been in the industry for like a long time who've been using Git, and a lot of them still don't know exactly how Git works. And I still learn stuff from Git. Like just a few months ago, I was talking to my younger brother who's a software engineer, and he was talking about this tool. And I'm like, wait, like that's built into Git? And I had no idea. There's a really, really powerful tool set, but we'll talk more about that too, because there's a whole bunch of fun stuff we can do in setup. But this is one that you want to make sure you set up as well. And again, it's on topic 1, and we can definitely walk through if we hit some little bumps and stuff. Okay, sound pretty good?